Everybody for joining me for another one of the Siemens online seminars. Today we're going to get a great opportunity to take a look at the long-awaited new released Siemens 4-axis post for Mastercam. So for those that may not be aware, we've been working directly with Mastercam corporate to help develop some Siemens-specific, validated and proved out post-processors. So we released, I think probably a year ago now, we released the first 3-axis post-processor, maybe a little longer than that. And we've just released the new 4-axis post. Come in the future, we want to expand this process. We're going to do a turning post and hopefully even get all the way up to a 5-axis post. So certainly the intent here is that we give the resellers and the users a great starting point from a post perspective. There's going to be cases where this may not be 100% fit. It might need to be tweaked a little bit, but I think it gives us all a really solid starting point. Okay, just give me 1 second here. I have a gentleman, I think that's, run to a login issue. So let me just respond to him and we can continue on. Fortunately, I had a feeling this might happen. All right. Introduce myself again, or for those of you that may not have had a chance to listen to me before, my name is Chris Pollock. I am what we call the Virtual Technical Application Center Manager, or abbreviated for short, we call it VTAC. And basically all that is it's a program that we've put together that's driving Siemens-based content on social media, the internet, the web. So obviously like the webinars we're doing right now, but we're doing a lot of little how-to videos, trying to get more content onto YouTube, that kind of stuff. So you're going to see a lot more stuff coming out over the course of the year that's being driven by this initiative, this VTAC initiative. This is my chance to queue up and kind of prep you guys for some of the webinars that's coming in the future. However, at this point we got MTS coming in September, so we're all ramping up for that. So I want to take a chance to actually talk about something we're doing at MTS that I'm pretty excited about. So in trying to get more awareness to what we're doing, not only with the virtual TAC, which I just mentioned, but also our physical training center, which I've talked about in the past, and I'll give you the links in a second. To promote that, we've actually created our own booth space at IMTS, and we're going to have basically a mock classroom set up. So I'm going to have some machine simulators, we're going to have some tape set up, presentation center, and I'm even bringing in a milling machine, and we're going to present a series of 8 different topics, and then we're going to run those over the course of the show and do little half-hour training seminars. So one, obviously, is going to be some pretty good content in there. So we're hoping that people come in and attend and spend a little bit of time with us, and they're going to learn some of these topics. But 2, also they get a chance to see some of the resources we have available for training, both based on web or if you attend our in-person classes. What they're going to look like is they're going to be half-hour blocks. We're going to do 4 segments a day, and the topics you see on the screen. So first day, we're going to kind of concentrate around conversational-based programming, shop mill. And we're going to be specific to milling in these because obviously I have a milling machine right there with me in the booth. We're going to do some simple introduction to shop mill. Then we're going to get into a little more topics, talk about the DXF converter. Then we're going to do a segment on part probing or probing and part inspection through shop mill. And then we're going to end that up at the end of the day, talking about trig help functionality and get into more advanced topics in shop mill. Is going to be a G-code day. So we're going to do an introduction to G-code, and then later that day we'll get into advanced G-code and using DXF. So kind of following the same format. From there you're going to get into the probing topic like we did in shop mill, but now it'll be all G-code based. And then we're going to end up with an advanced topic. We're going to get into variable programming a little bit and kind of introduce everybody to some of the more complex and advanced sections of programming. that 2-day sequence and just keep reading it. So Wednesday will be a redo of Monday's content, and then Thursday will be a redo of Tuesday's content, and throughout. So as you get into the show, you want to come by, stop by, either just to say hi, or if you have a little bit of time and you want to sit in, please come on down. You don't have to register, just show up for the time slot, and it's kind of a come first serve scenario. So if the space is available, you can come hang out. We're going to do some live cutting demonstrations, make all kinds of cool stuff set up. So that's we're going to be East Hall. Our booth numbers there in front of you. So that's what coming in September. So we're all real excited about it. Obviously, the webinar content is here. So for those of us that may be new to the series, you can always get to whatever next webinar is coming up right on the CNC webinar link that you have in front of you. Or you can access all of the previously hosted webinars. So the recording like we're doing right now gets posted on the CNC for You website, and then you can go back and check that out. And then from the in-person training perspective, we have a training seminar or training lab out in Chicago, Illinois. We call it our Technical Application Center. So if you use the CNC training link or you drive to that, this is where you can see all of the in-person instructor-led classes that we offer. And these are all complimentary. They're anywhere from 3 up to 5-day courses. So if you're looking to get into whether it be for basic entry-level content or you want to get into advanced topics, we have a whole range from simple 2-axis milling all the way up to 5-axis milling. We have turning. We have a pretty well-staffed and set up a by all means, check it out, and hopefully you can come in and work with us there. Today's topic specifically relates to the 828 and the 840 control. So the posts we were developing are pointed, directed at these two controls. So this post, if you have either of these products, you can be using this post for it. What we want to do today is I'm going to show you the kind of new features and functions we've incorporated in this post. That kind of makes it a little different than the 3-axis post we've already released. So we're going to talk about Cycle 832. We added some new functionality there than was previously released. Took all the drilling cycles and got them to fully support 4-axis toolpath. So we're going to talk and show you a couple different scenarios of drilling, but all the drillings, the standard CAN drilling cycles in that post will work with any 4-axis toolpath. We increased the functionality of the Workpiece blank because now you're on a 4-axis machine. There's some different features available, so we're going to look at that. New application guide, so we'll dig into that a little bit. That's published and released by Mastercam, and that'll reflect a lot of the stuff we're talking about today. And some higher level pens like F groups we're going to get into, and just some things we did just to simplify, streamline the editor from our perspective. Into utilizing the post, we're going to talk to you about how to get, what you can do, how to modify it up. So first and foremost, what was the post designed to really support? Well, 2 core applications. So I can do kind of plain style milling. That would be like 3+1 scenario, where maybe it's a tombstone or just a part where I need to position and do some 2 to 3-axis toolpath on. Post is fully integrated to support that kind of functionality in different planes and orientated in Mastercam. We go in and we can fully support 4-axis, multi-axis toolpath. So you're doing kind of machining where you have to have simultaneous rotary and linear movement together. The post supports that as well. So really kind of application you would run into from a traditional 4-axis toolpath. The system has the ability to support both vertical, horizontal machine tools, really any scenario that you'd come into. Now, certainly there could be some custom applications that might need some tweaking, but like I said earlier, the base post should get you 90–95% there. Okay, so the first question whenever we get into these posts is, how do I get it? How do I get posts? And there's a couple of ways to get it. Certainly, if you actively are working with a Mastercam reseller, I would reach out to the Mastercam reseller, let them know about the post, that you've heard it, and they can certainly provide it directly for you. But if you're a registered user of Mastercam, and have a a physical dongle or a licensed copy of Mastercam, you can create a login on mastercam.com if you don't already have one. And once you've logged in, then you gain access to what's called the Tech Exchange. So come log in with your credentials, mastercam.com. Under support, you're going to find the Tech Exchange pull down. And with the Tech Exchange, that's going to come in and you can browse to any number of posts, our posts included. You're going to pick the version. Not posts are going to be supported in all versions. Generally, what happens is we usually support it in the last two latest versions. So we first did the 3-axis post. We wrote it for 9 in 2017. However, it'll be updated, so it gets updated to the newer versions. But 4-axis post, that was written and designed around 2018 and 2019. So the post is available under both releases, but you wouldn't find it for X9 or 2017. We got to keep moving forward. It's hard to try to always go backwards all the time. So just some incentive to stay up to date with the current releases of Mastercam. Now, with that, just a post and you're working with it, it's not a bad idea to come in and take a look and see what the latest post-release revision number is. It's not necessarily going to get any kind of notification if we added a feature or updated a bug or something in the post. But what we'll do, and you can set in the lower red box, is there's a number assigned to every post. So come in, take a look at the version number. I'll show you in a few slides where to find the version number at post level. And it's just one of those things where, maybe every now and then you want to come in and check just to see what the latest one is. Or, God forbid, you were having a problem. That would be probably the first thing I would do, is come in and check to see if you're running the latest release of the post. Okay, what happens there is, once you log in and you pick the post, it's a simple download. You're going to unzip it, and there's some files. And one of the files you're going to find in there is a PDF, and that's what we call application guide. So this was published by Mastercam, and it steps you through kind of all of the unique functionality that's in the post. It also steps you through how do I install the post, how do I get it and get it running. So what you see here is pretty much parallel in that application guide. So if you're going to grab the post, if you're going to implement it, then you certainly want to kind of follow the application guide, and it'll step you through how to install and set up the post. But I'm going to do that as well today, so we're going to look at that quickly. You come, you unzip it, and you're going to get a series of files. So you're going to have a control definition file. You're going to have just a few machine definition files, and you're going to have a file that has a PST and a PSB extension. So real from that, the first files you want to pay attention to are the PST and the PSB. And it's what's going to get copied into your post folder. And the folder is found in your shared Mastercam 2018 or 2019 directory. That shared directory, you're going to find mill, because this is a mill post. And then you'll find the folder for posts. So you copy those two files into that directory. The rest of the files, so the files with a MMD extension or control extension, are all going to go to the same directory, and that's your CNC machines directory found under the root of shared Mastercam. Now, where shared Mastercam is, it's really up to you and your install. So I can't necessarily tell you where you installed it to. You can have changed the path on it. I think it naturally wants to install to my docs, but don't quote me on that. I certainly have mine set up in my docs. But just do a search if you don't know where it is. Just find the shared Mastercam folder, and then that's where you're going to drop the post. And you notice with the machine definition files, we are supporting a vertical machining center or a horizontal machining center. So once you download this, you'll be able to support either kinematic type. Now, the vertical is going to be a standard out-of-the-box A-axis rotary. So if you have some kind of different combination, that's where you would have to do some tweaking. And I want to say, if memory serves me, the horizontal, that's going to be a C-axis style, or not C, I think it's a B-axis rotary combination. But again, if you are slightly different. There'll just be a little bit of modification or tweaking to the post to get it to comply with that system. So we files, we move the files in. Now the post is available. So let's talk a little bit about some of the key features we're going to highlight in today over the course of the next hour, and some of the things we're going to concentrate on. Now, what notice is from the 3-axis guide to the 4-axis guide, there's a lot of similarities. So really kind of use the 3-axis content as a building block to develop the 4-axis post. So all the functionality that was there in the 3-axis post is found in the 4-axis. Then we expanded it, and the expansion necessarily just 4-axis topics. So there are some new features. So one of the things we added were these groups. Groups is a simpler way to kind of navigate through our control, and we'll show you that. We added some new functionality, cycle 832. There could be features that you're going to see here that would easily apply to the 3-axis post. And what we'll do, take some of these features, and we're going to kind of go back, and we will be planning to update 3-axis post, but it'll gain all of the functionality that you're now seeing in this 4-axis post. Topics that we're going to talk about, we're going to talk about groups, the Workpiece blank, we'll get into cycle 832, we're going to show you a little bit about the drill, and then we'll talk about feed groups, some more advanced topics, and then talk about home position, rotary axis, a couple other things. So one of the things, when you look at the new post, you're going to see that the format looks a little different. So Mastercam implemented a new format from their side. I really like it. It makes navigating the post a little bit easier. The post you see on the left, that's the original 3-axis post. And here it was just line by line from start to end. You just kind of had to, work way down through the post. Now they've added these things where you basically have like blocks or groups that can be expanded or contracted. So if you notice in that little book to the right, there's regional revision log or region features and notes or common user switches. So either of those plus keys can be expanded or contracted. So now if I know that, hey, I'm usually making most of my modification in the switches section, which is where we do a lot of the modification, I can quick come down, get to 284 while I'm looking at that first screen, open up, and I'm just concentrating in that area. So it's just really a navigation thing, but certainly it has made it a little bit simpler to navigate through the post. So if you have 3-axis post, you've watched the previous webinar, you're going to see that it's just going to look just a little bit different. Now, there are the posts where they've always kept the support or the revision control numbers, the version revision, is right at the top of the post. So you see it right on line 2. You're going to see a number. Now, the first digit of the number, so the 20 in this case, that always reflects the Mastercam version. That's never going to change. So 20 is actually signifying 2018. If there was a value of 21 there, that would be 2019, and so on and so forth. So any post that get released for 2018 will always start with a 20, but after the decimal point, those last 2 digits, those are going to reflect the version number of the post. So in the case, the latest revision release of the 4-axis post is .83. So you make sure that that's the one. And like I said, from time to time, go to the Tech Exchange, take a look. It's quick, easy. You see it right there in the notes. That you're running the latest post, maybe worth downloading and taking a look at the latest one. Now, just be careful. Done a lot of modifications to the post you're running. The new post know that, so you would have to make those updates if you download the news post. So there's functionality that we incorporate in the posts we call switches, and switches really just allow me to turn on and off features in a post processor. So give you an example. Back in the 3-axis post, which we reflected again here, we allow tool naming. So in the Siemens control, you can give the tool a number, T1, T2, T3, or you can, it's a half-inch handle, it's a 3/4 inch. I got a change sound that I heard. I just want to make sure everybody's still got my audio. I want to make sure we didn't drop out. No, doesn't stop. Everybody, somebody could just type into the chat window real quick. I would appreciate it. Okay, good. Well, don't know what that was, but we're going to keep moving on. That was a little strange. Okay, thanks, guys. I appreciate that. Okay, so the switches, this just allows me to turn on and off functions. So like the tool naming. If I don't want tool naming, I don't have to use tool naming. I can just always use tool numbers. I've just changed the yes to a no. If there's multiple options you're going to see in some of the later ones, then we give you a number value and then just pick the number. And the post writer did a really great job of putting a lot of notes and detail inside this post. So if there's any question, read through it. You're probably going to have a pretty good shot of understanding exactly what he's asking you for, what the functionality is. And certainly by the end of this webinar, I think you're all going to have a real clear version, view of it. But if you don't remember, again, it's the note there to kind of steer you to be able to adapt the post. Okay. Let's start with our first function. And our first function we added is the group function. So inside the post switch on line 305, like I see on the top, there is a output underscore group. And right now I have it set to yes. Now at the output toolpath, if I post out 3 or 4 operations like you're seeing on my operation toolpath window on the left, I'm going to see in the G code initially, at least in the Mastercam editor, is this little that says group begin, and then syntax string. It'll tell you what operation number you're looking at. And then further down in the toolpath, you're eventually going to see group end. And that's all. I just get a couple extra lines. But what it does in the Siemens control, it allows you to have, just like you kind of saw in the Mastercam posts, the blocks that can be expanded and contracted. So I'm right looking at 3 different operations of toolpath. If you look down after op 3, I see on one page up to sequence line 18,814. So what we basically took the core toolpath, right, the option which is usually just a lot of G1s and G0s, moving around in space, and we condensed them inside these groups. And the editor, I can open and close the groups. To bring up Sinutrain, and I go into a Mastercam file. So you're going to, in the editor, you're going to see this line that says groups. Really, if you're just on a line and you hit your blue arrow to the right, it's going to expand. Now you're going to get all the toolpath for group to have contracted it by using the arrow to the right. It'll compress them. So I can quickly expand and contract. It was we took out really the stuff that you need to know right off the bat. If I'm going to quickly look at a toolpath, what's one of the first things I want to know? Well, I probably know what operation I'm in. It's a valid thing. I'm going to want a tool, at least speeds and feeds, right? So we kept that simple, more common stuff that you would always want to look at just above where we put the operation tab in. And then really left the core code, right, the base toolpath here down inside the meat of this. So if you need to get to a given line, take a look at some other things, you can quick expand it. But if I'm looking at 4 or 5 different operations, I get down through the operations real fast, right? So I had a couple different operations. Let me see if I have one that has multiples. If not, we'll be putting something a little later anyway. No, it doesn't look like I have something with multiples at this point. But had a multiples, I would see op 1, then op 2, just like you saw on that previous slide, and I can kind of zip down through it. So that if it's something that for software version, we've had them for a long time, but if it's you don't want to see, just set that switch to a no, and it won't actually show it. So the simplest way to get into the post to start to modify different things in the physical post is you want to post something out in Mastercam. So be in some toolpath, really doesn't matter what I'm going to post, and you want to tell it I'm going to post out the toolpath. You're going to get a little pop-up window here. I'm just going to let it overwrite whatever file's there, but I'm going to let it edit it. And this is the trick. I want the Mastercam editor to pop up. I'm not about posting. Oh, well, I probably have. Yep. Be careful if you have Sinutrain running at the same time. Mastercam don't like it if I try to post into a file that's being edited. I can't blame it. All right, let's go back to it. Let's post it again. All right, post the operation. It's going to bring up our editor here. So your editor, this is the toolpath. Here's our group statement, like I mentioned. That's from that switch. And what to do to get to the post is simply use the open command, automatically point to the folder for posts. So you see it right here. So where that post folder is, it automatically points there. You just have to change your file type to post file. And that is all files with the PST extension. Now remember, where there were two files, PST and PSB, you're only ever concerned with the PST file. PSB is an encrypted file. It's nothing that you can edit. But all stuff that you need to worry about is found right inside this PST file. So highlight, click open. It's going to bring it up as a separate tab. And like you can kind of zoom in, right? This is the post, what we're running. So I said all your stuff's down here in the switches section. This is pretty much where you do almost all of your edits. So come to switches, you can hit the little plus key. We expand up, and now we're in the post switch section. So I'll change my groups. I just come down where it says yes. I change that to a no, just like you would see here. I don't have to even click post. I can leave this up in this little editor, and then you'll see that it's not outputting the group. Or any of the functions we're about to kind of go through right now. That's really, I mean, it's not very complex to get in and start to modify that basic stuff. Now, you be careful where you go inside the post. There's a lot going on there. So it's, be careful when you start to change stuff. It might not hurt to, save a backup file of the post to a different name. Just you stepped on something. Okay. So this is groups. Now from there, the next thing we added, which is found in newer versions of our software, we brought this clamping functionality in version 4.5. So if you have old software on your machine, 4.4 earlier, you won't be able to take advantage of this clamping function. Or it really depends on how the builder commissions it. Generally, you don't see the clamping option if you don't have a 4-axis machine. But once you have a 4 or 5-axis machine, so a machine with rotaries, then you get this clamping field. So if you have a clamping option, what that does is it allows us to orient cylinders now in the direction of the rotary axis, where before, without clamping, all of our cylinders were always pointing in Z. And on an axis machine, that's not really where I would want them, right? I want them rotating about my x-axis on an a-axis rotary, or my y b-axis. Here's a perfect example where you want to read the notes. So saying machine supports clamping and workpiece blank with a question mark. So that's the question to you. Hey, does your machine have the clamping option? So give the machine, create blank. If you're clamping, you got it. So then just to a yes. And I want to say, I think the default is yes. If you don't have clamping, don't output it because it won't be able to use it. When you look at the output code in the cycle string, you'll see there will be the axis that our clamping is oriented in, or what I'm clamped on, as it'll match the rotary axis that this was commissioned for. When you set it to a no, it's going to go back to its normal orientation. Now, if you've turned clamping on, your cylinder has to be oriented in Mastercam in direction of that rotary axis. So when I set up the cylinder and I wanted it to be pointed in Z, maybe I have the 4-axis post, but I'm working off of a vise or something, and I'm not really using it. Well, if you have clamping on, it's going to tell you that you can't do that because we're expecting it to be oriented in the 4th axis. So you have a couple options there. You can turn the clamping to no if you want to do that. You not worry about the blank here at this point. Maybe even turn the blank off and then just set it up out the machine tool. Remember, when it comes to the works blank, you don't have to output it. That was a post switch. So if we looked back at our post switches, we down here. Where are we? I think we're down. Yep. So here we can work on the clamping or the blank, and we can also suppress the workpiece blank. So you're going to kind of tweak that in either scenario, depending on how you want it to function. If you're not sure if your machine supports it, just go over to the machine, open up a program, G-code or conversational, shouldn't matter. Now G-code, you go to the various screen, you're going to go to your blank option. Now if you have clamping, you're going to get a clamping field here, and that can toggle it back and forth. Now, if you're on a 5-axis, you'll see the 2 rotaries here usually in a lot of times. Clamping field's not there, you don't support it, you want to leave that at a no. Comes to shop mill, our conversational program, and I'll just do thing just to get it. See that in the header page, right? So if I have it here in shop mill, I would see it here in the header page. Of course, everything we're posting is going to be G-code, so that's really I'm more concerned. But if you have it, it's going to be in both places. Oops, the new clamping feature. If I'm working off a bar stock, it does make it nice to be able to drive the orientation right from Mastercam. Advanced surface. So prior to this, we didn't really refer to our high-speed routine as advanced surface. It was just Cycle A32. The advanced surface is actually the back-end function that was automatically being called by Cycle A32. The creation of the 3-axis post, we here at Siemens have released a new algorithm for our high-speed machining. So it's basically got some new tool strategies. It is an option in our control. So even if you're running the newer software, it doesn't mean you're necessarily going to have it. But the option is called top surface. It's going to be one of those things. Again, you're going to want to check out at your machine. I'll show you how to check it in a couple different spots, because it won't always necessarily even be a selection in Cycle A32. This is where it kind of depends on how the builder set up your machine tool. He may be forcing you to always run top surface. If the case, then you're going to get this selection. It's just going to look like as if it was advanced. So I was going to show you 2 different ways when we get to the control of how to validate it. But with Mastercam is we now give you the ability of telling us, instead of automatically getting, which was the original option 1, now you got 5 options really of how you want to set up and handle high-speed toolpath. So on our format 1 is the way the 3-axis post was set up. So what it does is that is a standard numerical string that always reflected the machining taste. So is it roughing, semi-finishing, or finishing? 3 is roughing, 2 is semi-finishing, so on and so forth. Now originally we supported this format because this was this went back the furthest versions within the Siemens control. So I was running a system starting with 2.6 software right up through. They all support this decimal format. And that's still true today. So if I have a brand new machine running the latest, greatest software, and I just have advanced surface on the machine tool, I'll still run this decimal formatting. What we did from the Siemens side is we changed the format to also support a verbal or a string variable inside the cycle call. Underscore rough was in place of 3. The functionality from the control side was exactly the same. We said, well, do we really need to have 2 options? Well, when we did the advanced surface, they didn't really need it. But with a new feature, we figured, what, we'll support all of them. So if I selection of 2, I'm only going to get advanced surface, but I'm going to see this rough, semi-fin, or fin variable get output in the cycle call. So now have format 3 or 4. Those now use the top surface function. Now, format 3 is going to always output a numerical value and work in the latest, greatest code. And then format 4, which we get to in a sec, you'll see a verbal statement. Now, when you get to top surface, there's a new trigger, there's a new option here. So even if I have a machine running top surface, I may want to toggle between advanced surface or top surface, And I may want to turn on or off a function we call smoothing. So this new option under your miscellaneous values allows you to kind of control what the SIGLA32 output is going to look like. So this in the actual operation of your toolpath. I pick pocketing cycle and I want high speed to be on. So option 1 has smooth off. So if I looked at the control, once I push this in, you're going to see the smoothing option would be off. And then a value of 2 would be smoothing on. And a value of 0, that would get advanced surface, not top surface. And you'd see this would say advanced surface. Format 4, which is probably the most preferred if you're going to run top surface, it's going to output the string variable or just a named variable inside, and you can still toggle. So from an operation standpoint, no matter what we have the post switch 3 or 4, it's going to be the same way. So 0 is just advanced surface, 1 smoothing off, 2 smoothing on, but running top surface. So I'm using it and trigger it. Again, I would be in some toolpath in Mastercam. And in this toolpath, you're always going to see a miss values section. And this is where you turn it on. So you want to unselect the checkbox if you can't edit it initially. And then you're going to see a few options. So there's really 4 options within this. And this kind of stayed the same as it was in the 3 axis, except for this new top surface function. So the first question is, do you want Mastercam to kind of figure out if you should be using advanced surface or top surface, if you should be using the high-speed routine, or do you want to manually override that? More times than not, you're probably going to pick a manual override. If you generally are going to know a little better than Mastercam whether you should use it. The toolpaths, that Mastercam, it was pretty obvious to Mastercam that this is a high-speed roughing or finishing style toolpath, and specifically it's all in the 3D surfacing toolpaths. So all that is, if you have it set to auto 0, it may not output SIGLA32, but you're letting Mastercam make the decision. If you set it to 1, it's never going to do whatever the next line says. And the next says a 0 value would say off. So no, there's no SIGLA32 running at all. Or to pick the operation type. Now, why would I want to force it to be off? If you use top surface or advanced surface, is linearize all our toolpath. So that all output toolpath is just the line moves. And that's because of our spline compressor. I mean, there's all kinds of reasons behind it. We could probably talk for another half hour just on this topic alone. But today, if I look at my toolpath, I'm always going to just see G1s with advanced surface or top surface on, with SIGLA32 on. Well, I want to have arc moves. Maybe it's not really a high-speed toolpath, and I want to have a much smaller program, so I want G2s and G3s. Well, force that to be off. It's going to output, depending on how I have the configuration file set up. But generally, by default, that's what it would automatically do. But now that I want to use SIGLA32, then I just pick the physical strategy, right? Roughing or semi-finishing. And you have the smoothing function if I want to use top surface or not. We just talked about that. And the other thing is the chordal tolerance. So a lot of times you may not necessarily know what chordal tolerance you want. So leave this to a 0, then the system's going to automatically output the default values for either rough finishing or finishing. If you know what your chordal tolerance you want, playing around with different tolerance types for different toolpaths, then you can force that. Just type in the number. And then, an inch, you're going to be, I would say, anywhere from thou max in a roughing scenario. Usually 4 to 5 thou is pretty standard. Finishing, you might find yourself going all the way down to a couple tenths of an inch. Okay, so from there, we now did the features and functions for our drill cycles and drilling cycles in 2 different formats. So first, we have kind of a plane-by-plane scenario. So in the plane-by-plane, here I would have created some form of a plane within Mastercam and then do some features to it. So whether I have 1 hole or 10 holes or whatever I have on this plane, I will be working off that plane. So there's a standard drilling style routine like you see here. And then I would be driving based on a plane I've created. And my tool plane and my construction plane would be based on that. So I have the work coordinate system always top and drive the tool geometry based on the active plane or the plane I chose, right? So this may be plane 3 was one of them I chose. And from there, the system will then output a rotor move to present plane, set up my modal call. Now in this scenario, I only had one hole, so it only put out one. But if I have a couple holes on this surface plane, that would be my 2 or 3 or 4 holes between my 2 modal statements, my M calls. She'll swing to the next plane if I was going to jump to a couple planes like you see on this image, and I kind of move back and down. So that's a very typical method for me to be outputting toolpath. I would kind of do this plane by plane scenario. Also supporting kind of full simultaneous 4-axis, not necessarily simultaneous, but the ability of doing multi-axis drilling scenarios. So in this case, I'm going to use a multi-axis drilling path. And now I can pick a few different holes. And the system, I just want to make sure I'm setting it up as a 4-axis output. Certainly don't have 5-axis on this machine. And tell it the way my rotary is oriented. So I have an axis rotary, so it's about X. And now I'll get a bunch of positions, including the rotary move in that position. So in the earlier example, I could have done that one of 2 ways. Now I did that little routine plane by plane, but I could have picked all the holes and let it output in one shot. Say we're going to do that real quick just to kind of give you a simple example of it. So here, my toolpath, right? Here we got some operations, and I had some holes on some different planes. One hole at a time, or one plane at a time. There could be a few different holes here. I wanted to kind of run around all these holes in one shot. You can to multi-axis, pick drill. Now the system's going to allow me to come and drill those holes. So I want to pick my pattern. Right, so I'm going to use a few holes, and you'll notice as I click on them, it's going to arrow. That's pointing in the direction of the tool, so it should be pointing up to the tool. I'm going to walk around and get however many holes you want. So let's say there we go. We got the 4 holes. Holes. Now we would define a strategy for drilling the holes. I can leave it as default as a pretty simple one. And make sure that our tool axis control is set to our 4-axis and our rotor is working around our axis. You could give it some collision control if you wanted to. There's a bunch of stuff in here. I can define, now normally I would set these values to 0 because this would add or subtract from the that I chose, right? But you found the routine, and now I'm going to get toolpath for the 4 holes. If I was path here, and I simulate it, you'll see we're going to now handle all 4 holes, one routine. Track that was just my default retract value. Certainly I could bring that a lot closer. That's just tweaking the numbers within the cycle. But the big and post it, you'll see it'll automatically handle that, and that's but still using our CAN cycles, not having it output just standard G1 and G0 routines. So if we were to take that new operation that we created, we're going to post that out. I don't need to worry about editing it. Just post it out, ba-boom. And if we jump over into now, op17 is now here. And if I hit op17, I will see that I got a nice, clean, concise drilling routine. So I did the part earlier with different planes. I had a lot of holes on the given plane. That would be my method choice, certainly. Well, I have holes, wrapped around a rotary. I probably would choose to use the 5-axis toolpath. But either way, you're still building our standard cycles. You're still going in and defining your start and that kind of stuff. Okay. So just to give you a little feel what's going on here. Boom. All right. So that's the multi-axis or the 4-axis drilling support, like we mentioned. So moving along, and I want to present a topic, and this is a little bit of a detailed topic. It's a tendency to kind of throw guys for a loop a bit, so I want to spend a little bit of time talking about it. And that's a function called feed groups, and then the additional supporting command of our feed group reference. Okay, so function will depend on certainly how your machine has been set up or commissioned. But in our control, depending whether or not the rotary is part of this feed group command, really handling how my feed rate is being calculated by the control. So generally, the standard rule default, or if you're getting and you have to assume the machine was set up some certain way, the standard way most OEMs or builders commission these machines is that all rotaries are part of the feed group calculation, just the linear axis. Because when I go to calculate and I do a move that's including a rotary, those always end up at the same point in space at the same time, right? If I tell it to do a X and an A move, she's never gonna end up getting there in the A first. But is feed rate is generally a behavior of the axis that's got to move the furthest distance, right? So if you thought about a simple 3-axis mill, Z at 100 inches per minute, and physically move 30 inches, and Y and Z are only moving 2 or 3 inches, right? From wherever I was at to where I'm going. Well, there's an axis that's moving at 100 inches per minute, and that's just one, so that's in this case X. Well, rotary isn't part of the feed group. It's basically telling us that, hey, you can let this rotary move faster than normally we would expect it to, because we're concerned about the rotary. We're only concerned about the next longest move, which is the linear axis. So I'm about to show you only occurs when the rotary motion is the longest move of the axis pair, right? If the rotary is these tiny little small segments and the linear is always moving further, this scenario doesn't really come into play. So I built a little program example like you're seeing there to demonstrate this concept a little bit. So I have this feed group program, and all this is I'm telling the machine I want to do an X and an A move, but I'm moving the A 1,080 degrees. So that's obviously a lot longer than a 10-inch move. I'm going to cut out my feed groups right off the bat. We're going to take a look at the resulting cycle time, because that's what this really is. It's a behavior of cycle time, of how long a tool path is going to take to run. So this part, I'm running it at 10 inches per minute. I'm not taking any rotaries into account. If I look at my cycle time, it's a minute to run. Well, if I'm moving max 10 inches at a feed rate of 10 inches a minute, I should take it. And the little bit of time was the pre-position, those couple of seconds here. But how far the rotary traversed, right? If I was to take this little spiral and pull it out and make it straight, the actual green tool path that the cutter went, right? Let's zoom in a little bit. I think this green line is longer than 10 inches. But if it's not enabled, it's saying, I don't really care what the rotary does. I can go a little faster because I want to just calculate feed based off of linear. Well, in a part geometry like this, I now had a much higher chip load, or different chip load, higher in this case, than I'm expecting. So I could get tool degradation, surface finish qualities, all kinds of problems can start to arise. So we have a function we call feed groups. So if I go into the part program, I can enable the feed group command. And what the group command is going to allow me to do is that's going to allow me to now tell the system, hey, I want A to be included in the feed rate calculation. just going to run here with our cycle time. All I did was uncomment one line. Now look at the cycle time. It is now calculating that my rotary is part of this calculation. So now it's going 4 minutes and 24 seconds. So 4 minutes, basically, the exact same move. Go to feed groups. What we now need to know is, where am I in relation to the center of the rotary? Right? I think of that spiral. If I'm an inch out on a rotary radially, that length of spiral is going to be much bigger than if I was 1 inch out. The F comes into play. This is your reference. Default, if you don't tell it anything, you just boot up the system, there's a machine data that sets it, but generally it's set to 4 inch or 100 millimeters by default. So outside of that range, I'm still getting a missed calculation. So I can come back and now tell it, okay, maybe I'm at a 1 inch radius. There's this reference to know how far away from the center of the rotary the tool physically is. Set it to 1 inch, we run it. Remember, we were just at 4 minutes 30. I cut my cycle time in half. Put myself back out to a larger radius. So in our case, this part, I think it probably was a 4 inch diameter part, 2 inch radius. Actually, yeah, I was cutting at 1.9. So right here, I'm at 1.9. I set the 0 in this scenario just to be simple as the center of my part. So if I put this to 1.9, and this is a radial value, now I execute, and I should get as close to the optimal chip load as I'm expecting to. So this feed groups scenario even exists is keeps you from having to jump into inverse time or all sorts of different other feed strategies. But the reason why we don't always include the rotors in the feed groups is when I get to a 5-axis machine and I'm using functionality, what we call rotary tool point compensation, traori, the rotary in scenario never actually moves the tool along. The tool is only moving by the linear moves. So the rotary only changes orientation. In this case, on a 5-axis tool path, if I have a feed group on, I'm actually giving up cycle time, and it has no bearing. Anything, it's slowing down my tool, so I'm reducing my proficiency. I'm reducing my load, but I'm also losing cycle time. So standard rule of thumb, if you are running traori, then you do not want your rotaries to be part of your feed group command, and you don't have to give this stuff. But if you're not using traori, and your rotary axis has a direct result of the motion that the tool is going along the part, like you saw on our nice little spiral here, you want to start to implement feed groups. So in post, and hopefully that's a little clearer. It's one of the concepts that it's easy to show once we get to a real machine. But hopefully you guys kind of got that. From the post side, we have a group function inside the post. It can be on or off. So if you're just doing that, plane by plane kind of tool path, you're not doing any simultaneous, and you don't want to worry about seeing feed groups, you can just set post switch to a no, and then you're not going to get any feed groups. Have it to a yes, and you're going to set up what we allow to be the amount of deviation you can be before it outputs another feed group reference, or FGREF, right? So if I'm at a value of 1.6 and I'm getting, I'm moving down on a 50 thou or 100 thou and up 50 thou as far as that reference radius. We want Mastercam to be outputting a bunch of FGREFs. It's not going to hurt it, but it's not really necessary. Now, you move up and down within a half-inch distance, you're not going to see a huge difference in feed rate. So that's this value is, and then the metric equivalent. So the smaller I make that number, potentially the more FGREF references I'll see. I find a lot of tool paths, unless you don't have, unless you huge deviations or differences in relation to the radius of that rotary, you may only get one, two FGREF references. But setting the right reference is critical. Now there, you're going to have these names, right? And name is spelled out in the feed group string, right? So it's important that you get these names right. And we've got it again, the label's right in the post, but this machine data it reflects. It's not always necessarily XYZ. Even though your machine always reads XYZ, the builder could have labeled the channel label X1, XX, some other crazy terminology. You don't see that from an user until you get to some of these higher level commands. So if you're pushing what you would logically think to be as XYZA, and the system's giving you a syntax alarm to the machine data and see what values are entered here. These values there need to be reflected inside of the post switch. And if I go back, you need to see the exact values that are pushed into the cycle string. So that's where that comes into play. So make those right, or you will get an alarm. Here, to give you an example, how I put a pretty small tolerance in that deviation value, how to start to output multiple feed growth references. This is okay, but it's not really doing a whole lot for me. So like I said, I would leave it at the default, which I believe we set to a half an inch. Should be more than close enough. But if you're running into some surface quality, if you're really trying to get that perfect finish and you think that this is hurting you, tighten up the tolerance a little bit. You'll just get more references out of the system. What would happen if we didn't have the feed group command? So what's happening is the system, by default, is going to look at this group of parameters, this feed group default axes. And if you read a little bit about it, what is if these values are all at 0, I'm only going to use the geometry axis as part of my feed group reference. It's possible that an OEM set up a machine that will default to using the rows as part of their feed group. Yes. In that case, is me putting the feed group again going to help me? Nope, it's not going to hurt you either. It's just a duplicate command to what they set up. So check your machine if you want to be 100% sure of how it was commissioned by looking at these MDs, or push the feed group. I would say a standard kind of gut reaction, if you're doing simultaneous 4-axis toolpath, 4-axis machine, and you don't have Traore, which you generally would not, output feed groups. It's not going to hurt you. It's going to help you, trust me. Okay. Next thing that you will have to make sure that you modify or support within the post is your 4th-axis brake if you're using a brake. So brake, and you need to trigger the brake. One, if you want to output the brake command, no scenario, right here in the post switch, axis locking, use rotary axis locker codes. And if this is a yes, then it's going to use by default M10 and M11. But an area where you may need to go down into the post and modify this in a different section. So look under region string select, look up table NC section down at block 945. This is why the M codes we're pushing out. So builder, every builder assigns different M codes when it comes to your 4th-axis brake. So you get your M code list, and you're going to want to update the post. So just to show you, if I start to scroll down a little bit, I need to get into, I think it was 945 or something thereabouts. Or not 945. What was I just looking at? Hold on. Oh yeah, 945. Okay, good. So you get down to line 945. There it is. Boom. There we go. 945. Your M codes. Certainly, you could also just do a quick search for M11, and it'll find it here. So our machine was an M14, M15, or 13, or whatever. Just use the M. Leave the quotes, because that's what's pushing it out. So use the M11 or the M10 to match unlock and lock. And that's important, obviously. You don't want to get those backwards, or the timing's going to be all wrong. But that's a very common one you're going to have to tweak, because trust me, every OEM does it differently. Now you'll inconsistencies in the OEM. So if you have a lot of Fryer machines, for argument's sake, they'll use one set of M codes. G, somebody different, or Hyundai, or whoever, MCO, let's say. So you always want to check from the manufacturer what M codes he used. Okay. With that being other options, and then we'll open up to some questions here. So we had the home position before. That's our SUPA, machine track to some safety position. In just kind of streamlining and simplifying some things, we are now adding a variable top of the program so you could quickly change this value. So before, if I wanted to change my SUPA line, I had to go into the post and I had to edit these numbers. So to kind of drive it to some different locations, or if I'm moving this program from a couple different machines, I would have to find where the SUPA line was, make a manual edit there, or try to update the post and post it. So what's going to happen is right at the top of your program, you're going to see the variables automatically. So I don't have to go searching through the program to find the 50 different SUPA lines I have. I can make a quick update right at the top, and that's going to be the number it uses for every time it does a SUPA command. So by default, use the default home position. So you can type in whatever number you want if you know you're always going to say the same value on your machine. But once I get to the machine, if I need to edit it for any reason, get a fixture in the way, whatever I'm doing, look now, as long as we have that turned on, which we do on mine, these two lines. Now the deadline, you're never going to edit that you need to leave alone. But what you're going to edit these values. So if I wanted my machine to go to a machine position of positive 10 inches, I could type here, and down at the bottom of the program, it would substitute this value for that variable. So if I have SUPA commands before every operation or sprinkled through the toolpath, this saves me from having to find a bunch of different places to edit it. One of those kind of niceties that simplifies supporting the toolpath once you get out at the machine tool. Now, when it comes to the rotary axis output, there's a couple different ways you can set it up. And this was a point, a lot of discussion between myself and Mastercam when we were building this post, is how to make this post be as universal as possible. To get to different builders, there's a ton of different ways to set up just something as simple as a rotary axis. The shortest path, does it go longest path? Is it driven as what we call a modulo axis? So every time it goes 360 degrees, does it return to 0? Or does it continue to accrue so I can tell it to go to 10,000 degrees, but then I have to unwind the axes, right? A bunch of different ways. So by default, what we did was we set up the system to use the DC command. And DC command basically says, I'm going to, no matter how the machine was commissioned, I'm going to move this path. And I found in all sorts of different strategies, I found that that's certainly the best, the most consistent. Now, there are going to be certain scenarios, depending on how your OEM set up your table, where it may the way you need it to or you want it to. So there's another way to set it up, which I'm going to show you here in a sec. But by default, you're going to see all these A equals DC command. It says, hey, I'm going to move 6 degrees, but I'm going to get there in the shortest path. That's all that's telling you. If I have this to a yes, that's what I'm going to see in my output. Have it to a no. Now it's going to be dependent on the machine definition file. And remember, we had copied all those files in before, and a bunch of those were machine defs. So you would have to go into the appropriate machine def file, and inside the machine def, right in here, this is how I would drive. Is it signed continuous, signed direction, shortest direction, all being now looked at. So if this is here, no matter what you set the machine definition to, it's going to do the shortest path. But if there's a no, then it's ended on this page. So if you have to tweak the machine because it's commissioned differently, you would have to go into the machine control definition manager, in the axis, and then you could tweak it as needed. In that scenario, you're going to just see the rotary axis output without the DC equals command. Sometimes guys at first don't understand the syntax and they think it seems a little foreign. But me, I would leave it yes, try math first, working the way you expect it. Then I would say, go in, set it to a no, and you can try to tweak it a little bit and see if we can get there. But like I said, the most common scenarios I threw at it, the DC seems to work on all of them. That certainly makes the post the most universal we can get it. So there's only one last topic that I wanted to talk about here, and then we're going to open up to some questions. So as I'm talking about this last topic, you're all welcome to start typing in some questions too into either the Q&A or the chat window. Q&A would probably be a little easier for me because we do have a bunch of chat stuff already in there. And this is really just more of, I wanted to make you aware of a scenario that occurs with the Siemens control that can throw guys off a little bit. Show you how we combated it inside the post. So generally, when you're programming in a Siemens control, you're programming everything in feed per minute, right? So a linear type of feed rate. And if I add rotaries to it, doesn't matter. It's still always programming in feed per minute, right? So 100 a minute, I'm moving on my way. Well, it's all well and good until I get to a scenario where I do not have any linear axes moving at the time of the rotary axes. So what occurs, the says, well, I can't calculate a linear feed because I'm not doing a linear move. I'm doing a degree move, right? A rotary move. So we'll automatically switch its time base to degrees per minute. If I think about the rate of speed of 100 inches per minute, that's pretty quick, right? That's moving right along. The equivalent of 100 inches per minute switched to 100 degrees per minute is super slow. So the scenario that you would see is I'd be doing a bunch of, air and rotary cuts at the same time, and then I would get to a position where just the rotary had to move. The system would automatically change its time base. So you see right in my TFS window, I'm now reading degrees per minute. I didn't program degrees per minute, but if we're only a rotary, I have to be in degrees per minute. And now all of a sudden the machine's going super slow. So to combat this behavior, because this is always going to occur, there's nothing you can change in the system to prevent this. It's just the nature of how the Siemens control works. We do what's called a non-modal feed change, or your FB equals command. So what Mastercam's doing is saying, hey, if I detect any rotary-only moves, I'm then going to calculate where I am in this from my radius, and I'm going to calculate the equivalent of the linear feed I was running at. So example, sorry guys, in this example, I was at 50 inches per minute. So mathematical equivalent of that, based on where I am in the radius, would be 1,469 degrees per minute. So we're put in FB equals. Now, you're going to see this on every line because this is a non-modal move. We did modal because it would keep us from having to necessarily reinstate the feed. In this one, it happened to push it back in, but it's not required. It would automatically reinstate the feed rate if I were to, just on the next line, next natural line. So I'll only see the FB equals on the axis lines that's just a rotary moving by itself. And then the system's going to return back to its original linear feed rate, and I'll only see it switch back again when this condition occurs. So I have a little program example here. So in this path, you start to see the switches between the two. So I just wanted to run this real quick and show you kind of the behavior as to what happens. So I'll crank down my speed, so it's going a lot slower. And if you look at the program toolpath, you're going to see, excuse me, all right, I'm going to default to G94, right, because I'm not telling it anything else. And that's why I'm in a feed case inch per minute mode. So I cycle start, he's running, doing a thing. Now watch what happens when I get to just the rotary commands. The system's automatically switching you in degrees per minute. Why? we need to increase the feed rate, so maintaining the same tool speed, right? Same speed at my cutter, because that's my critical portion. And the further I was on the radius, the faster I would have to move, because the further distance. So it's kind of a little bit like the feed groups I were talking about earlier. But in this case, it's just a matter of feed rate, of speed. If you have a lot of decimal places outputting, you're probably this condition a lot less, because you're more likely to have a linear move with it. I try to make a pretty severe case so you can kind of see the behavior. But I'm not doing anything to switch this. The program's not doing anything to switch it. The control is doing it on its own, because it sees a move of just a rotary that doesn't include a linear. So with that said, I think we're at a pretty point. We are going to open up to some questions. Certainly my contact information is here too for those of you that would like to reach out to me. But it looks like we got some questions here, so let's start to go through them. It's controlled by a miscellaneous integer, or must you edit the post to turn on and off? I believe you have to modify the post to turn it on or off. I do not think that we anticipated a miss here. This is a 4-axis pocket, right? So this is our top pocket. And if I go to my geometry, let me bring that over. And we do not for allowing you to force it. So if you have the clamp on, then the system's automatically going to handle it for you. So it'll turn it off. Would not have a way of overriding that without turning on or off in the post. Okay, good question. Get the post and the related docs. So back to what I mentioned earlier. What you're going to do is you're going to want to go to mastercam.com. You want to log in. So you see I'm logged in now as a user, but you get into whatever your user login is. If you haven't created a login yet, just come in here, create the login. It's going to ask for your SIM number. It's pretty minor. I didn't need to do much when I created mine. It was a while ago. But, then you go to support. You're going to exchange. And that's the way to remember. And what change? Is she thinking? Yep, she's thinking. It's going to tech exchange. Pick the appropriate version. Oops, sorry. It's weird. My screen. Pick appropriate version you want to go to. You can put in Siemens. You can do a search for all of them. What we're doing, and then you'll find it. Here you see the 2018 version. From there, just download the zip file, and you're going to get the tech exchange doc, like I mentioned, and all the posts and all the files that I just showed you. All right. Yes, and a validation from Don, our post writer extraordinaire. He did say correct. There is no miscellaneous value to control the rotary axis locks. It's all driven from the post. All right, what else do we have here? Okay, here's one. Can I post a 3-axis toolpath with the 4-axis post? So certainly you can. He says I can't. In fact, I did on this part, right? I happen to have bottom toolpath. I was just doing some simple 3-axis toolpath on, or maybe this is just a simple vice job. The only downfall is it's always going to output the 4th axis, right? So if I'm just working on vice and my 4th axis is set aside, I'm probably going to see it at least spin to 0, and then I'm going to do everything on that base tool plane. Now, obviously, if you're disconnecting the 4th axis on your machine tool, which is pretty common, then you're going to run into a problem because it's still going to output the rotary commands. So it's kind of the difference. If I need it to not output any 4th axis stuff, then I would really have to go back to the 3-axis post at this point. Keep reading here. Will this post run my 808 control? That 4th axis. Okay, that's a very valid question. So the 808 is very similar to the 828 and 840. So the bulk of this toolpath will absolutely run in your control. Really, the big thing that you want to be careful with in the 808, it's running a little different version of can cycle when it gets to drilling. That and the work offsets are a little different because we don't support the full expanded range work offsets, just G54 through 59. But what I suggest if you want to use this or even the 3-axis post for an 808 is you have to not allow it to output the can drilling cycles because they will not work in the 808 at this point. So what you have to do, you can actually inside of there's just a couple options inside the control def editor, if memory serves me, and you can select whether or not you want the system output can cycles. If you to no, and just let it output G1s and G0s for your drilling cycles. And yeah, this should certainly work in an 808. Trying to think that in the work coordinate. Oh, and you want to get rid of the workpiece blank. Workpiece blank didn't exist in the 808, but other than that, it should work. Okay, let's see what else we got. If I run into any issues with the post, who should I contact? So really, the line of defense is always going to be your Mastercam reseller. So I say, if you have a problem, reach to your reseller. They'd be able to steer you in the right direction as to whether or not there's a post issue or maybe you just need some support. But that's really always going to be step one. Reach out to that reseller. Now, as far as the post, you can request a reseller, or certainly you can go to the tech exchange, just like I showed you. Okay, I think I got all the questions. This was some great questions. So with that being said, I'm going to end our recording. I want to thank everybody again. Hold on one